Okay, so I want to go through the quiz that we did on Friday, November 16th. Alright, so we're going to correct the quiz. Quiz correction. Quiz correction. And this is for Monday, November 26, 2012. Alright? So the question number one asks you, it says that Molly runs 1/3 of a mile in 4 minutes. And it asks you a few questions. So we're going to deal with the questions one at a time. Part A asks us if Molly continues at the same speed. Molly continues at the same speed. How long will it take her to run 1 mile? Okay? And they want you to show work and explain your reasoning. Alright? So you should show work and explain your reasoning. Now, like I said to you in class before, you can actually use a table to do this problem. You can use a table to do this problem. So we have that 1/3 of a mile, right? 1/3 of a mile is run. Notice I'm using that arrow, not an equal sign. Is run in 4 minutes. 1/3 of a mile is run in 4 minutes. So basically we want to find out how many miles can be run in, how many minutes rather it would take to run a whole mile. So we can make a table and explain our reasoning as we go. So here we have number of miles and we have number of minutes. Okay. So the number of miles, we're given that for 1/3 of a mile it took her 4 minutes, and we're assuming a constant rate here. So if she runs another 2/3, another 1/3 rather, so we know that 2/3 is the same as 1/3 plus 1/3, and that would be 4 plus 4. 4 for the 1/3, 4 for another 1/3 equal 8 so far. So far she runs 2/3 of a mile and it took her 8 minutes. And now we know that 1, which is the same as 3/3, is the same as 2/3 plus 1/3. Alright? And that's going to be the same as 8, because it took 8 minutes to run 2/3 of a mile, plus if I run another 1/3 it takes me 4 minutes. So finally it's going to take 12 minutes. Okay? So your conclusion would be it takes 12 minutes to run 1 mile. Okay, it takes 12 minutes to run 1 mile. So it takes Molly 12 minutes to run 1 mile. Okay, and we're going to move on to the next problem. Let me erase the board. Okay, you should be thinking about this problem while I'm going on to the next problem. Okay, this is academic intervention. This is what we do. We go over problems that we don't understand in class. Okay, so the second part asks us, so 1D asks us to draw and label a picture showing why your answer in part A makes sense. And I told you that you could use a graph, okay? So my suggestion to you was make a graph. Okay? Make a graph. Okay. So now, if I'm going to make a graph, I need to have the axis. That's the y-axis here, and here is an x-axis. And I want to have a reasonable scale. So notice my scale, I'm trying to be as even as possible. 1/3, 2/3, and 3/3, which is equal to 1. And this is, here I have can I do something different here? Okay, so I want to do something different. I want to use a time instead. So time normally goes on the x-axis. 4, 8, 12. And this is time in minutes. Okay, so this is time in minutes. And here I have 1/3, 2/3, 3/3, which is the same as 1. Okay, so 3/3, that's equal to 1. And here I have the number of miles. Okay, and so I'm told that she does that for in 4 minutes she covers 1/3 of a mile. So since she's going at a constant rate, I would expect her to cover another 1/3. I would expect her to cover another 1/3 in 8 minutes. And finally, in 1 minute, I would expect her to cover a full mile, okay? So in 1 minute I would expect her, in 12 minutes rather, I would expect her to cover a full mile. Alright, and here we go. So I draw a straight line. Okay. And this is the point that concerns us. This point is 12, 1, okay? where this is the time in minutes, and this is the number of mile. Okay, in this case, number of mile or miles, I would say mile. Okay. Alright, so that is number one. Okay. Number of miles, I'm not sure. You can look that up. Alright, so your line should be straight. I'm doing freehand, so my line is not as straight as it should be, but your line should be straight. Now we're going to move on to number 2. Okay, we're going to move on to number 2. Number 2 gave us a table. We had a table in number 2. And the table looks like this. It's talking about 3D movie ticket prices. 3D movie ticket prices. And we're given that we have number of tickets in the left column, number of tickets in the left column, and we have a cost in dollars in the right column. Okay, and you are given that one ticket costs $12. Okay, and by the way, this right here would represent the unit rate. Okay, so this row would tell us about the unit rate. Okay, the unit rate is $12 per ticket. That would be the unit rate. So think about that information. And 2 tickets would cost $24. Of course, 3 tickets likewise, keep adding $12 would be $36. 4 tickets would cost $48. And this information is given to you. Alright? So this information is given to you. Now, you are asked to create a graph using this information. Alright? You are asked to create a graph using this information. And I'm going to try to see if I can make a graph. Utilize the space as much as possible. I'm going to make a graph. So again, I need y-axis, I need an x-axis. Okay, and since the cost depends on the number of tickets, I'm going to put the cost on the y-axis. So I start out with 12, then I go to 24, then I go to 36, then I go to 48. Alright? And I have my origin there, and for number of tickets, I count 1, 2, 3, 4. Notice that my scale is even on both axes. My scale is even on each of the axes, or each of the axes. So this represents here the number of tickets. Okay, so the number of tickets is on the x-axis, and the cost in dollars is on the y-axis. So right here I have the point 112. One ticket costs $12. Then I have 224. Then I have 336, and finally I have 448. And I just draw a straight line. You should be using your ruler. You have a ruler through that graph. And since they told me to stop at 48, I stop right there. Okay? But of course we can see that the line would continue through the origin, right? So I can make the line go through the origin, because 0 tickets would cost $0. And let me see, I could actually continue up. So if you have 5 tickets, then you can conceivably pay $60. That's what you would pay. Okay, so notice I have my graph. The cost is labeled, okay? And this is, I can label this movie tickets, okay? Label my graph, well, 3D movie tickets. Give your graph a name. Okay? So that's how you do a graph. Alright, so that's number 2. And I'm going to erase this now and go on to number 3. Actually, before I go on to number 3, there's one more part of number 2 that I must talk about. So 2b, they ask us in 2b, explain what the points, explain what the points 0, 0 and 1, 12. Explain what the points 0, 0 and 1, 12 represent. Okay. Now we all know what this means. We know that 0, 0 is the origin, okay? And we know that the origin tells us something about proportionality. So you can answer, your explanation will be based on the given table. The fact that 0, 0 is a part of the graph. Okay. When we extend the line, when we extend the line, tells us that the relationship between cost and the number of tickets is proportional. So if you mention anything about proportionality in your answer, you will get the full credit or almost all of the credit. Okay? The point (1, 12) represents the unit rate. Okay? That is 1 ticket costs $12. Okay? So that's what you should have, or you should have had on your test. Okay? That's what you should have had on your test. Alright, so we're going to erase 2b and we're going to move on to number 3. We're going to erase 2b and move on to number 3. Okay, so number 3 has another table. This time we are talking about pizza recipe. You are told to determine if the relationship between the two quantities is proportional. Determine if the relationship between the two quantities is proportional. So they expect you to show some work or explain why you would come to the conclusion that you come to. Alright, so that's given to us as a problem to solve, and we are given information here. So we have pizza recipe, and we have number of pizzas. We also have the cheese, the amount of cheese in ounces. Okay, OZ stands for, the letters OZ stand for ounces. Okay, so for 1 ounce we have, for 1 pizza we have 8 ounces of cheese. For 4 pizzas we have 32 ounces of cheese. For 7 pizzas we have 56 ounces of cheese. And for 10 pizzas we have 80 ounces of cheese. And you can answer this question with or without a graph. Okay? So if you want to talk about the number of ounces per pizza, so here you can set up some ratios. So you can have number of ounces, okay, over number of pizza. Number of pizzas, okay? Number of ounces over number of pizzas. And this here would give you, the first one, you have 8 ounces for 1 pizza, so you have 8 over 1, and that ratio is equivalent to 8. And likewise, for the second one, you're going to have a ratio of equivalent to 8, because 32 over 4 is also equivalent to 8. And for the third one, you got 56 over 7, which is also equivalent to 8. And here you have 80 over 10 is also equivalent to 8. Okay, so there's a constant ratio, okay? The ratio is constant, okay? So the ratio is constant, okay? The ratio is constant, which is the unit rate here. This ratio is a unit rate, 8 ounces per pizza. And so, in answer to your question, is the relationship proportional? Okay, you would say yes. You would say yes, the relationship is proportional. So, the relationship is proportional because we have a constant ratio of 8, which is the unit rate. Okay? A lot of you made the mistake of trying to do a graph without a proper scale, and then you ended up getting that it wasn't proportional, but the relationship is proportional because there is a constant ratio. Okay, the ratio is constant. In this case, this constant ratio gives us a unit rate of 8 ounces per pizza. Alright? So think about that. Now I want to draw a graph. Showing you how you could have done this, answer this question using a graph. Or you could have explained the same concept using a graph. So, if you're going to draw a graph, you have to have a constant scale. So this is another way of answering the question. Number 3. Instead of doing the constant unit ratio, the constant ratio, you could have done a graph. You could have drawn a graph. And so this graph, you're going to have the ounces of pizza, okay? So ounces of cheese. Ounces of cheese. And down here you're going to have the number of pizzas on the x-axis. Okay, and notice here, I'm going to start at 0. It's going to be important with the origin. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The mistake that some of you made was that you just wrote out the 1, the 4, the 7, and the 10 from the table without having an even scale. You can't just put numbers on the axis. You have to have an even scale. Okay, now we can count by 8 on the y-axis, 16, 24, 32. And again, some of you, when you were doing this, you just wrote the numbers down on the axis. You just wrote down the numbers that's on the table. No, you have to have a uniform scale, even scale. So you have 32, then you have 40, 48. Yes, 48, you go 56. Here you go 64. Okay, after 64, you have 72, and then you have 80. Even if you're not using all the numbers, they must be a part of the scale, because you have to have a uniform scale. Alright? So now we are given on the table, let's use the points on the table. We're given 1/8 on the table. Okay? This point right here on the table is 1/8. So we're given 1 pizza takes 8 ounces of cheese. We're also given a point 432. Okay, 432, somewhere around here. Okay, we're given 4,32. Again, takes 4 ounces of pizza. Take 4 pizzas rather. 4 pizzas need 32 ounces. Okay, 4 pizzas need 32 ounces. See that? And you are also given for 7 pizzas you need 56 ounces. Okay, so 7 pizza, 56 ounces, somewhere around here. Okay, so 7 pizzas take 56 ounces to make. And finally, you're given that 10 pizzas take 80 ounces. Okay, which is you naturally expect. And so I'm doing a freehand drawing. Of course, one thing before I go ahead and draw, notice that 0 pizzas would take 0 ounces. You're not making a pizza, you don't need any cheese. Okay, so that should be a straight line. If you have a ruler, you would make a straight line. Okay, and I can label my graph pizza recipe. Okay, do you see that? So, in response to your question to explain is it proportional, your conclusion would be the relationship between the two quantities. So the two quantities you're given are the ounces of cheese and the number of pizzas. Between the two quantities are proportional, because when I drew an accurate graph has to be accurate to make sense. The line goes through the origin. Okay. Again, the relationship between the two quantities are proportional, because when I drew an accurate graph, the line the line went through. Okay, the line went through the origin. Again, the relationship between the two quantities is proportional. What happens to me today? The relationship between the two quantities is proportional, because when I drew an accurate graph, the line went through the origin. Okay? And now we're moving on to number 4. Moving on to number 4. Okay, number 4, as you can see in your paper, in number 4, we are given a graph, or we're given some points in a graph. Try my best to sketch them right. I think we're given 4 points. And of course, this is 1. The x-axis. 2. So notice my scale is even, is about even. Try my best. 3, 4. This was the time in seconds. And up here you have, this is 1, this is 2, 3, 4, 5, 6, 7, 8. Okay, I'm drawing the best even scale that I can. It's not perfect, but you have a ruler. Okay, so you're told that this is a number of beats. Here we're talking about number of beats, okay? Continue up. Okay. So y-axis, so x-axis, 5, etc. And you're given heartbeat of a cat. This should be familiar to you. We did a heartbeat assignment. Heartbeat of a cat. And you are asked, the question that you are asked here is, which point represents the unit rate? So let me label the points. This point is 1, 2. This point is 2, 4. this point is 3, 6, and this point here is 4, 8. Okay. I want you, before I answer the question, I want you to notice something. Notice that the points that you have here, you have 1, 2, right? Notice that if you take this point and multiply it by 2, both parts by 2, 2 times 1 is 2, 2 times 2 is 4, you get the second point. If you take the same point, 1, 2, and multiply it by 3, 3 times 1 is 3, 3 times 2 is 6, you get 6. You take the same point and multiply it by 4. 4 times 1, 2. 4 times 1 is 4. 4 times 2 is 8. So obviously the point of that circle must be represent the unit rate, okay? So your explanation would be 1, 2 represents the unit rate. One, 2 represents unit rate because it tells us that for every 1 second, alright, or just for every second, the cat's heart beats 2 times, okay? Or you could also explain that 1, 2 is a unit rate because every other point is a multiple of 1, 2, okay? Alright, so 1, 2 represents the unit rate because it tells us that for every second, the cat's heart, not hearts, the cat's heart beats 2 times, okay? Or you can say that every other point is a multiple of 1, 2. Therefore, 1, 2 is a unit rate. Okay? Notice here, if you're going to have the unit rate, it has to have 1. Point has to have 1 in there. This 1 tells us that it takes 1 second for the cat's heart to beat 2 times. Okay? Finally, number 5. The problem that most people had a struggle with. Number 5. Number 5. So, number 5, I will not write out the question. I will read the question and I will draw the table. It says Darrell recorded the greenhouse temperature at certain times of the day in the table. The greenhouse, as advertised, read it again. The greenhouse in advertised to maintain a temperature. There's a typo here. The greenhouse is advertised to maintain a temperature of 65 and 85 degrees, between 65 and 85 degrees. Suppose the temperature increases at a constant rate. Okay? So let me read it again. Darrell recorded the greenhouse temperatures at certain times of the day in the table. The greenhouse is advertised to maintain a temperature between 65 and 85 degrees. Suppose the temperature increases at a constant rate. That's what you need to note. So we're given here time and we're given temperature. Time, we're given the temperature in degrees Fahrenheit. Okay? So at 1 o'clock p.m., at 1 p.m., the temperature in degrees Fahrenheit is 66. At 6 p.m., the temperature in degrees Fahrenheit is 78.5 degrees. And for 8 p.m., the table lists a temperature of 83.5 degrees. Alright, now you are asked to find the unit rate. And this is a challenging problem. Okay, so this is something that unfortunately you did not learn in class. Before the review, we did a quick review on this. Alright, so now I'm going to give you a formula for unit rate that you should memorize. Unit rate is equal to change in one value divided by change in the other value. Okay, I know this seems vague, but in this case it's going to be change in temperature, which I will write as TIMP. Don't have this TEMP. Change in temperature divided by change in time. Alright, change in temperature divided by change in time. And I will continue over here. This will become change in temperature. I can use any of these. I'm going to use this one because it's easier. I'm going to do 83.5 minus 78.5 divided by, and by the way, this change is going to be in degrees Fahrenheit, okay, divided by time. Here we're going to just put 8 hours for 8 p.m. minus 6 hours for 6 p.m. and this is going to be hours, right? Alright, so when I do that, I'm going to get 83.5 minus 78.5 is going to be 5. So it's 5 degrees Fahrenheit divided by 2 hours, which would give me 5 divided by 2 is going to be 2.5. So it's going to be 2.5 degrees Fahrenheit per hour, okay? So that is the unit rate. Again, your unit rate is 2.5 degrees Fahrenheit per hour. Okay? So that's your unit rate. Now you are asked to create a new table which shows the hourly rate from 1 to 8 p.m. Okay? You are asked to create a new table that shows the hourly rate from 1 p.m. through 8 p.m. and I will erase. Okay, so now I'm going to create a table. This is 5 part B. And the table is going to have time. And over here it's going to have temperature on the right. Temperature. That's going to be in degrees Fahrenheit. Okay, so now we're given at 1 p.m. just like we were given the temperature was 66 degrees. So therefore at 2 p.m. you add the unit rate. Recall the unit rate is, we found out that the unit rate was 2.5 degrees Fahrenheit per hour, right? So we're going to use that fact to help us here. So at 2 p.m. you just add 2.5, you get 68.5 degrees Fahrenheit. At 3 p.m. you add 2.5, and 0.5 to 68.5 would give us 69 and 271. At 4 p.m. temperature would be 73.5. At 5 p.m. temperature would be, like you expected, it would be 76. And at 6 p.m. temperature is going to be 78.5. Just like they gave us, okay? So that's why we know we're doing the right thing. At 7 p.m. temperature would be 81 degrees Fahrenheit, and at 8 p.m., just like they gave us, temperature would be 83.5. Okay, now they want us to create a graph and explain whether or not the relationship would be proportional, alright? So we're going to create a graph. We're going to use a little bit of a space on the right side to create a graph. So if I'm going to create a graph, I need to have an even scale. Okay, what would 0 mean in this case? What would 0 mean in this case? 0 in terms of time would probably go back to 0 would probably go back to we can go back to midday if we want, but if you want to go back to when the day started, 0 would be at midnight, alright? 0 would be at midnight. Now, let's just think about something here. How many hours do you need to go back from 1 o'clock to get to midnight? If you go back 1 hour, you end up at midday. And if you go back to 12 hours, you would end up at midnight. Right? So let's just look at this little calculation. So 13 hours before 1 o'clock would be midnight. So let's say I have 66 degrees Fahrenheit, okay? And I want to take away 13 times 2.5, okay? So I want to do 13 times 2.5, which I'm actually going to use my calculator. I can do it by multiplying it long, but for time's sake, I'm going to use my calculator. So that would be the same as, this would be equal to 66 degrees Fahrenheit minus 32.5 degrees Fahrenheit, which would get us to 33.5 degrees Fahrenheit, okay? Now, notice that this number is not equal to 0. So we know right away that the graph is not going to be proportional. So we don't have to go back to midnight. So what I'm going to do here is I'm going to make my 0 12 p.m., okay? I'm going to make my 0 12 p.m., alright? And so this 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., over here. Oh, I need to do a better scale. I'm not going to have enough space. So let me make my spaces a little more close. So this is going to be 1, this is going to be 2, 3, 4, 5, 6, 7, 8, and so on. Alright, so these are all PM. So 1 PM, 2 PM, these are all PM. Let me just put that brace to tell you it's all PM. And this is going to be time. Okay? Or I could just put time in PM, same thing. Okay? So now I'm going to go by, I would probably go by 5s or 10, say 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, alright? And so this is the temperature in degrees Fahrenheit, alright? So I have my time and I have my temperature. Let's start plotting. Notice here that at midday, which I'm going to count as my 0, okay? I'm going to count 12 PM as my 0. 0, I'm going to count it as midday, okay? So at midday, the temperature would have been 2.5 degrees less than 66. So that's going to be 63.5, which is going to be somewhere around here. Okay, then at 1 o'clock, the temperature is going to be 66, which is like somewhere around here. At 2 o'clock, the temperature is going to be 68.5, which is just slightly above. At 3 o'clock, the temperature is going to be 71, which is like literally slightly above. Slightly above. See that? The temperatures are real close. And at 4 PM, the temperature is going to be 73.5. 4 PM, 73.5, again slightly above. The graph is kind of flat. And at 5 PM, it's going to be 76. This again, this is slightly above that. 5 PM is 76. 6 PM is going to be 78.5. Okay, 78.5, still less than 180. I mean, still less than 80. Okay. 7 PM is going to be like 81, slightly above right there. Okay. And 8 PM is going to be 83.5, which is slightly less than 85. And so, yes, the line is straight. It's a straight line. Doing the best I can here. You would have a ruler in your paper. It's hard using a ruler in this board and having you see what I'm doing at the same time. Okay, so of course the temperature is not going to continue infinitely, because then the place would burn up. Alright, so we would write, for you give a graph a name, and it would be greenhouse temperatures, okay? Greenhouse temperatures. Okay. And so the question that you are asked is the relationship proportional? And you can say no. The relationship is not proportional, or you can say non-proportional, because the line does not pass through the origin. So the origin is down here and the line is up here. Does not pass through the correction. Okay. Okay, so that was your quiz correction. I will not go over the extra credit because most of you should know how to do the extra credit, if not all of you. Alright, so I hope you see where your mistakes were by looking at your test, and I hope you learn from your mistake. Again, this video will be on YouTube, so please watch it when you get a chance. Thank you. Take care. Bye-bye.